Review for exam number 5. You'll notice when we have the numbers for the different questions that I have included the section numbers. So if you want to refer to the section numbers or for more information about any of these questions, you can go to that section, or of course you can always email me. Question 1A. Well, we are supposed to simplify each expression and then leave our answer in the simplified radical form. Do not bring these to the decimal representation. So the first one is with A is the square root of the quantity 25 minus 16. Since the expression 25 minus 16 is under the same radical square root sign, we will first simplify what is underneath the radical. And we end up with the square root of 9. 25 minus 16 is 9. Then the square root of 9 will be the principal square root, or just 3. B, the square root of 25 minus the square root of 16. Since 25 is under one square root sign and 16 is under a different square root sign, we will do each of the square roots individually. The square root of 25 is 5, minus the square root of 16, which is 4, gives us a 1. C, the square root of 16x divided by the square root of 2x. We can use the quotient property for radicals, which operates very much like the product property for radicals, and we can write this under the same radical sign. Now this can be done for products and quotients, but not for addition or subtraction. So what we are now looking for is the square root of 16x divided by 2x. You'll see that we have some canceling. The x's cancel and 2 goes into 16 8 times. So we will be looking at the square root of 8. Now to simplify the square root of 8, we will look at taking out any factors that are perfect squares like the 4. So I'll take the 4 out front because I can simplify the square root of 4. And then the factor that is not a perfect square, we put in the second square root. The square root of 4 is 2, and then we bring along the square root of 2. So the square root of 8 is 2 square roots of 2 is our final answer. Moving on to number 2. Use the product rule for square roots to simplify, if possible. Leave your answer in the form of a simplified radical, if necessary. So we look at A, the square root of 72, and we will look for any factors that are perfect squares. So with 72, I know that 36, which is a perfect square, is a factor of 72, and that we would have a factor of 2 left over. The square root of 36 is 6, and our final answer is 6 square roots of 2. B, the square root of 40x to the 4th. Again, we're going to simplify, first focusing on the coefficient and then the variable. With 40, a square root or a perfect square that is a factor of 40 is 4, and we would have a 10 factor left over. Notice 4 times 10 is 40. Now for x to the 4th, all even exponents on variables are perfect squares. Since we have x to the 4th, we will put all of x to the 4th under the first radical. Now let's simplify that first square root. The square root of 4 is 2. The square root of x to the 4th, well, we divide the exponent by 2, so we get x squared. So 2x squared times the square root of 10 is our final answer. C, the square root of 34. With the square root of 34, let's look at for any factors that are perfect squares. The factors of 34 are 1, 2, 17, and 34. None of them are perfect squares. So that means we cannot simplify And our final answer is simply the square root of 34. Number 3, use the square root property to solve 3k squared minus 48 is equal to 0. What we need to do is to get a perfect square on one side of the equal sign and everything else on the other. Well, we see that k squared. So the first thing I'm going to do is to add 48 to both sides. When I add 48 to both sides, I end up with the equation 3k squared is equal to 48. Next, I will divide both sides by a 3. After I divide both sides by a 3, I get a perfect square on the left of k squared, and 48 divided by 3, I get a 16 on the right. Now, to use the square root property, I take a square root of both sides. Again, notice the perfect square on the left, and I will do the plus or minus the square root of 16 on the right. The plus or minus has to be there on the side that has the number. The square root of k squared is k, and then plus or minus the square root of 16 would be plus or minus 4, and that would be our answer. Number 4, use the square root property to solve x plus 4 quantity squared equals 17. We already have a perfect square on one side. It is the x plus 4 squared, and it will equal our 17. I'm going to use the square root property by taking the square root of both sides, plus or minus on the right on the numerical part of the equation. On the left, the square root of the quantity x plus 4 squared is x plus 4. And on the right, we cannot simplify plus or minus the square root of 17. The final thing that we need to do is to subtract 4 from both sides. And x is equal to negative 4 plus or minus the square root of 17. Now, since they are not like terms, as one is a radical or a square root and the other isn't, we leave our answer like this: negative 4 plus or minus the square root of 17. Number 5, use the quadratic formula x equal to negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a, to solve the quadratic equation below. What I need to do first with the equation 2y equals 5y squared minus 3 is to subtract the 2y and get the equation equal to 0. Now when I do that, I end up with 5y squared minus 2y minus 3 is equal to 0, which means a is equal to 5, b is equal to negative 2, and c is equal to negative 3. Let's put the values into the quadratic formula. X is equal to negative b plus or minus square root of b squared. Make sure that negative 2 is in parentheses, minus 4 times a times c all over 2 times a. Simplify what's underneath the radical, and I can also say minus a minus 2 is a positive 2. Right, well, negative 2 quantity squared is 4, and then it would be plus 60, because it'd be negative 4 times 5 times a negative 3 is 60. So we get 2 plus or minus 64 divided by 10, which is 2 plus or minus 8 divided by 10. Now, since we have integers, we should simplify this one more time. 2 plus 8 over 10 is 10 divided by 10, or 1. or x is equal to 2 minus 8 over 10 is negative 6 over 10, or negative 3/5 when I simplify. So my answers are x is equal to 1 or x is equal to negative 3/5. Number 6, we're going to graph f of x is equal to 2 to the x. Now this is an exponential function. So I will start by making my chart of x, and then f of x equal to 2 to the x. Now, a value that we need to have, a few values that we need to have on this function is we have a negative 1, and f of negative 1 is 2 to the negative 1, or 1/2. And let's go ahead and look at the ordered pairs as well. 0, so f of 0 is 2 to the 0, and anything to the 0 power is a 1. So we have the ordered pair 0, 1. Put a 1 in. F of 1 is 2 to the first power, or 2. Let's go ahead and do one more. F of 2, if x is 2, f of 2 is 2 squared, or 4. We can stick in even one more. Negative 2, x is negative 2, f of negative 2 is 2 to the negative 2, and if you do some simplification, you get 1/4. So negative 2 1/4. So in putting this information and graphing them on the coordinate system provided, negative 2 1/4 is going to be just right above the x-axis. Negative 2 1/2 is going to be, again, above the x-axis, just between y being 0 and y being 1. Then we have the points 0, 1, 1, 2, and 2, 4. Now to graph these, we're just going to extend everything to the left, stays above the x-axis, and it grows exponentially. It goes very steep. If you put 3 in, f of 3 would be 8, f of 4 is 16, and that would be the graph of the exponential function f of x is equal to 2 to the x. Number 7, solve for x in the equation. 4 to the power of x plus 7 is equal to 16. So we have the property I'm going to remind you of. If a to the x equals a to the y, then x is equal to y. So this property is just means if we get the same base, then the exponents have to equal. So I can rewrite 16 as a power of 4. So 4 to the x plus 7, that's what we have on the left. And on the right, I can write 16 as 4 squared. Now the bases are the same, so the exponents have to be equal, which means I can now set the exponents equal. X plus 7 is equal to 2. Subtract 7 from both sides. X is a negative 5. Number 8. A sum of $10,000 is invested at an annual rate of 8%. Find the balance in the account after 5 years, subject to quarterly compounding. And the equation for compound interest is given to you. A equals P times 1 plus R divided by N, all raised to the NT power. Now, A, this is a reminder, is equal to the amount in the account. And, or we could say the balance at the end of the compounding. P is equal to the principal. And in this case, it would be equal to the $10,000. R is the interest rate in decimal form. So we would write 0.08 or 8/100ths. N is the number of times the interest is compounded per year. In other words, the number of times per year the interest is added to the principal. Now, since it is quarterly, N is equal to 4. And T. T is equal to the number of years, or a fraction of a year, but the number of years that the investment is in. And in this case, it is 5. So, filling in our information, we have A equals 10,000 times 1 plus 0.08 divided by N, which is 4, all raised to the power of 4 times 5. Simplify this one more time. It'd be 10,000 times 1.02, all raised to the 20th power. Placing this into my calculator, I end up with a new balance as $14,859.47. Number 9. Solve the compound inequality, graph the answer on a number line, and write it in interval notation. First thing we need to do is to solve both of the inequalities for x. So on the inequality on the left, I will add 5 to both sides, and the inequality on the right, I will divide by a -2. Graphing these on the number line to the right, if x is less than 10, we put an open circle, and it's everything to the left. For x is greater than 4, we do an open circle, and it's everything to the right. Now, since it is an and, we would need to look at where they intersect. And where they intersect is not including 4 all the way to 10, and then not including 10. Writing this in interval notation will be the interval from 4 to 10, not including 4, not including 10. Number 10. Solve the compound inequality, graph the answer on a number line, and write it in interval notation. First, we need to solve each of the inequalities for x. I will subtract I will subtract 5 from both sides of the first inequality. And then, or I would divide both sides by 4 on the second inequality. Correct that, it's not 4, it is 3. 12 divided by 4 is 3. Graphing them on the number line. For x is less than a -5, I'll put a circle at the -5, and it's everything to the left. For x is greater than or equal to 3, I will put a closed dot at 3, and then it's everything to the right. Now, since this is an or, we would say this is also a union. We will write everything that we see graphed on the graph in interval notation. So the green arrow points to the left. We'll go from negative infinity all the way up to -5. Open, right? So it's a curved bracket. Or we can put right the word or. We can also use union. Then we do a closed bracket at 3 all the way to infinity. Number 11. Graph the linear inequality 2x plus 3y is greater than -6. Remember, the graph is the answer to this inequality. The first thing that I will do is to subtract 2x from both sides. So 3y is greater than -2x minus 6. Next, I will divide both sides by a +3. So the inequality sign stays the same direction, and I get y is greater than -2/3 x minus 2. After this, I will graph the comparable line. Okay, so I will graph y is equal to -2/3 x minus 2, and I'm going to use a dotted line because y is strictly greater than -2/3 x minus 2. All right, so first I'm going to plot the y-intercept, and then I'm going to use the slope. I'm going to go down 2 to the right 3, and then I can go down 2 to the right 3. Grab my ruler, use a dotted line. Now I have to shade one of the areas in, which represents the solution. Since y is greater than -2/3 x minus 2, it's going to go up. Greater, it goes up, and I graph this area. And what that means is any point, any ordered pair that's in the shaded area is a solution to the inequality, or it keeps the inequality true. And that would be the answer, is the graph. Number 12. Given the set A, which is equal to the set A, B, C, D, E, F, the set B, which is equal to the set A, C, E, G, I, K, and set C, which is equal to the set G, H, I, J, K, find the following. First, A union B. Well, A union B is equal to all the elements, but we write each element once. Just everything that is in A included with everything that is in B. So they both have A. B is in A. C, D, E, F. Now that's everything that's in A. Now write also everything that's in B that hasn't already been written. So I've already written the A, C, and the E, but I haven't written the G, the I, or the K. That would be A union B. A intersect B. Oh, A intersect C. All right, A intersect C are the elements that both sets have in common. So I need to compare A, B, C, D, E, F with G, H, I, J, K. They have nothing in common. There is no intersection. So I can write this simply as open bracket, or I can say it's empty, or I can say that little symbol that is reserved for the empty set. Number 13. Given the sets, A is equal to the set of all x such that x is less than 3. B is equal to the set of all x such that x is greater than or equal to -2. and C is equal to the set of all x such that x is greater than or equal to 5, want us to write A intersect B. Well, we're going to use the number line. A intersect B is the same as saying x is less than 3 and x is greater than or equal to -2. It's the same as saying that. So let's go ahead and graph. So x is less than 3. Okay, everything to the left. So we circle 3 and we go everything to the left. Now x is greater than or equal to a -2. Okay, we do a solid dot on -2 and it's everything to the right. Our final answer will be close bracket on -2 all the way to 3 open bracket. B, A union C. All right, well, A union C. Well, let's go ahead and take a look at A and we'll graph that first. So A, and I should say that this is the same as saying A is less than 3 or x is less than 3 or x is greater than or equal to -2. All right, well, x is less than 3. We put a circle at the 3 and it's everything to the left. X is greater than or equal to -2. Circle, oh, C, excuse me. We should write or x is greater than or equal to 5. There we go. Greater than or equal to 5, we put a solid dot and it's everything to the right. Writing this in interval notation, we start from left to right, -infinity to 3, open bracket, union with a square bracket, 5 to infinity. Number 14, Venn diagrams. There were 100 people surveyed, and the results showed 57 people enjoyed country music. 46 people enjoyed both country music and rock music, and 9 people who did not like any kind of music. How many people liked rock music and not country music? All right. Well, I'm going to let C equal country music. And we know that the number of people that like country music is 57. I'm going to let R equal the people that like rock music. And the people that like, we don't know, we're looking for the number of people that like rock music. All right, so let's go ahead and label our graph. So the left will be C, the right will be R. Now, when we look at the information in the question, it said that 46 people, because we need to look at starting at the middle, working out what goes in this middle piece here. And that would be described as the people who like rock music and country music. And it says that a total of 46 people liked rock music and country music. So that goes in the intersection. Now, the next piece that we will look at is some more information. It says 57 people enjoyed country music. Well, 46 of them are already spoken for, right? So when I look at the number of people that like country music but don't like rock and roll, it's going to be 57 minus 46, or 11. Another bit of information that we are given is like 9 people who don't like any kind of music. They just don't like it. It's noise to them. So out here, you know, and I could describe this, I could put this little whole diagram. So the number of people outside of the circles would end up being a total of 9. What remains is the question we are trying to answer. How many people like rock music but not country music? That's our question right here. Well, there's 100 people total. So when I add up these three values, 9 plus 11 plus 46, that gives me 66. 100 minus 66 gives me 34. So 34 people liked rock, but not country. "46 people liked rock music, but not country." Now the review material. Every test after test 1 has a little bit of review material. And we are going to focus on proportions for this section of review material. So solve the proportion. X minus 4 divided by x plus 5 is equal to x divided by x plus 3. Well, what we need to do is we need to do some cross multiplication. And the means equal the extremes. So this will look like x minus 4 times x plus 3 is equal to x times x plus 5. Let's make sure I can read them well. Doing my multiplication or FOILing. On the left, I have x squared. Now, I did FOIL, but then I combined the two middle terms in my head. So x squared minus x minus 12 is equal to x squared plus 5x. If you subtract x squared from both sides, they cancel. I have minus x minus 12 equals 5x. Adding x to both sides, I get negative 12 is equal to 6x. And then dividing both sides by 6, I get x is equal to a negative 2. Next example. Given the similar triangles, triangle ABC and triangle PQR, find A and B. What we know about similar triangles is that they are proportional. So first, let's find A. Right here. Well, A is to 7 as 6.4 is to 8. A, multiply both sides by 7. A is equal to 5.6. A goes into 6.4, 0.8 times, and 0.8 times 7 is equal to 5.6. Find B. Here's B, and we say B is proportional to 6, or B is to 6 as 6.4 is to 8. Multiply both sides by 6. B is equal to 4.8. Number 17. Due to space problems at a local university, a 20-foot by 12-foot conference room is converted into a classroom. Find the maximum number of students the room can accommodate if there must be at least 9 square feet of floor space for every student in class. So this is 9 square feet of floor space, but the dimensions are 20 foot by 12 foot. So the area of the room, we need to know what is the area of the room, is going to be 20 times 12, or 240 square feet. So let's read it one more time. Due to space problems at a local university, a 240 square foot conference room is converted into a classroom. Find the maximum number of students the room can accommodate if there must be 9 square feet of floor space for every student in class. So X is equal to the number of students that the room can accommodate. So X students is to 1 student as 240 square feet is to 9 square feet. Notice how the units would cancel. X divided by 1 is an X, and 9 goes into 240, 26 and 2/3 times, or 26 students can be accommodated.